deposited on them. Dopants are impurities intentionally introduced to a semiconductor to modulate its electronic properties. Doping is the process of adding dopants to a semiconductor material. Integrated circuits are composed of many overlapping layers, each defined by photolithography, and normally shown in different colors. Some layers mark where various dopants are diffused into the substrate, called diffusion layers. Some define where additional ions are implanted, implant layers. Some define the conductors, doped polysilicon or metal layers, and some define the connections between the conducting layers, via or contact layers. All components are constructed from a specific combination of these layers. In a self-aligned CMOS process, a transistor is formed wherever the gate layer, polysilicon or metal, crosses a diffusion layer. This is called the self-aligned gate. 65 1p, see Fig 1.1. Capacitive structures, in form very much like the parallel conducting plates of a traditional electrical capacitor, are formed according to the area of the plates, with insulating material between the plates. Capacitors of a wide range of sizes are common on ICs. Meandering stripes of varying lengths are sometimes used to form on-chip resistors. Most logic circuits do not need any resistors. The ratio of the length of the resistive structure to its width, combined with its sheet resistivity, determines the resistance. Schematic structure of a CMOS chip, as built in the early 2000s. The graphic shows LDD MOSFETs on an SOI substrate with 5 metallization layers and solder bump for flip chip bonding. It also shows the section 4 fill, front end of line, bill, back end of line, and first parts of back end process. More rarely, inductive structures can be built as tiny on-chip coils, or simulated by gyrators. Since a CMOS device only draws current on the transition between logic states, CMOS devices consume much less current than bipolar junction transistor devices. A random access memory is the most regular type of integrated circuit. The highest density devices are thus memories, but even a microprocessor will have memory on the chip. See the regular array structure at the bottom of the first image. Although their structures are intricate with widths which have been shrinking for decades, the layers remain much thinner than the device widths. The layers of material are fabricated much like a photographic process, although light waves in the visible spectrum cannot burst to expose a layer of material, as they would be too large for features. Thus photons of higher frequencies, typically ultraviolet, are used to create the patterns for each layer. Because each feature is so small, electron microscopes are essential tools for a process engineer who might be debugging a fabrication process. Each device is tested before packaging using automated test equipment, in a process known as wafer testing, or wafer probing. The wafer is then cut into rectangular blocks, each of which is called a die. Each good die, plural dies, or die, is then connected into a package using aluminium, or gold, bond wires which are thermosonically bonded, 66, to pads, usually found around the edge of the die. Thermosonic bonding was first introduced by a calculus which provided a reliable means of forming these vital electrical connections to the outside world. After packaging, the devices go through final testing on the same or similar ET used during wafer probing. Industrial CT scanning can also be used. Test cost can account for over 25% of the cost of fabrication on lower cost products, but can be negligible on low yielding, larger, or higher cost devices. As of 2022, a fabrication facility, commonly known as a semiconductor fab, can cost over $12 billion to construct. 67. The cost of a fabrication facility rises over time because of increased complexity of new products. This is known as Rock's law. Such a facility features the wafers up to 300 mm in diameter, wider than a common dinner plate. As of 2022, 5 nm transistors. Copper interconnects where copper wiring replaces aluminum for interconnects. No dielectric insulators. Silicon on insulator, SOI. Strained silicon in a process used by IBM known as strained silicon directly on insulator, STU. Multigate devices such as Trigate transistors. ICS can be manufactured either in-house by integrated device manufacturers, IDMs, or using the foundry model. IDMs are vertically integrated companies, like Intel and Samsung, that design, manufacture and sell their own ICS, and may offer design and forward/or manufacturing, foundry, services to other companies, the latter often to fabless companies. In the foundry model, fabless companies, like Nvidia, only design and sell ICs and outsource all manufacturing to pure-play foundries such as TSMC. These foundries may offer IC design services. Packaging. A Soviet MSINMOS chip made in 1977, part of a 4-chip calculators A designed in 1970-68. The earliest integrated circuits were packaged in ceramic flat packs which continued to be used by the military for their reliability and small size for many years. Commercial circuit packaging quickly moved to the dual inline package, DIP, first in ceramic and later in plastic, which is commonly Cal-formaldehyde Novolac. In the 1980s, pin counts of VLSI circuits exceeded the practical limit for DIP packaging, leading to pin grid array, PGA, and leadless chip carrier, LCC, packages. Surface mount packaging appeared in the early 1980s and became popular in the late 1980s, using finer lead pitch with leads formed as either gullwing or J-lead, as exemplified by the small outline integrated circuit, SOIC, package. A carrier which occupies an area about 30–50% less than an equivalent DIP and is typically 70% thinner. This package has gullwing leads protruding from the two long sides and a lead spacing of 0.050 inches. In the late 1990s, plastic quad flat pack, PQFP, and thin small outline package, SOP, packages become most common for high pin count devices, though PGA packages are still used for high-end microprocessors. Ball grid array, BGA, packages have existed since the 1970s. Flip-chip ball grid array packages, which allow for a much higher pin count than other package types, were developed in the 1990s. In an FCBGA package, the die is mounted upside down, flipped, and connects to the package balls via a packagee substrate that is similar to a printed circuit board rather than by wires. GAR packages allow an array of input-output signals, called area I/O, to be distributed over the entire die rather than being confined to the periphery. BGA devices have the advantage of not needing a dedicated socket but are much harder to replace in case of device failure. Intel transitioned away from PGA to land grid array, LGA, and BGA beginning in 2004, with the last PGA socket released in 2014 for mobile platforms. As of 2018, AMD uses PGA packages on mainstream desktop processors, 69, BGA packages on mobile processors, 70, and high-end desktop and server microprocessors use LGA packages. 71, electrical signals leaving the die must pass through the material electrically connecting the die to the package, through the conductive traces, paths, in the package, through the leads connecting the package to conductive traces on the printed circuit board. The materials and structures used in the path these electrical signals must travel have very different electrical properties, compared to those that travel to different parts of the same die. As a result, They require special design techniques to ensure the signals are no corrupted, and much more electric power than signals confined to the die itself. When multiple dies are put in one package, the result is a system in package, abbreviated SIP. A multi-chip module, MCM, is created by combining multiple dies on a small substrate often made of ceramic. The distinction between a large MCM and a small printed circuit board is sometimes fuzzy. Packaged integrated circuits are usually large enough to include identifying information. 4 common sections are the manufacturer's name or logo, the part number, a part production batch number and serial number, and a 4-digit date code to identify when the chip was manufactured. Extremely small surface mount technology parts often bear only a number used in a manufacturer's lookup table to find the integrated circuit's characteristics. The manufacturing date is commonly represented as a 2-digit year followed by a 2-digit week code, such that a part bearing the code 8341 was manufactured in week 41 of 1983. Or approximately in October 1983. Intellectual property. The possibility of copying by photographing each layer of an integrated circuit and preparing photomasks for its production on the basis of the photographs obtained is a reason for the introduction of legislation for protection of layout designs. The U.S. Semiconductor Chip Protection Act of 1984 established intellectual property protection for photomasks used to produce integrated circuits. 72. A diplomatic conference held at Washington, D.C., in 1989 adopted a treaty on intellectual property in respect of integrated circuits. 73. Also called the Washington Treaty or APIC Treaty. The treaty is currently not in force, but was partially integrated into the TRIPS agreement. 74. There are several United States patents connected to the integrated circuit, which include patents by J.S. Kilby US 3,138,743, US 3,261,081. US 3,434,015 and by R.F. Stewart US 3,138,747. National laws protecting IC layout designs have been adopted in a number of countries, including Japan, 75, the EC, 76, the UK, Australia, and Korea. The UK enacted the Copyright, Designs and Patents Act, 1988, C48, 213, after it initially took the position that its copyright lawfully protected chip topographies. See British Leyland Motor Corporation v Armstrong Patents Company. Criticisms of inadequacy of the UK copyright approach as perceived by the US chip industry are summarised in further chip rights developments. 77. Australia passed the Circuit Layouts Act of 1989 as a sui generis form of chip protection. 78. Korea passed Act concerning the layout design of semiconductor integrated circuits in 1992. 79. Generations. In the early days of simple integrated circuits, the technology's large scale limited each chip to only a few transistors, and the low degree of integration meant the design process was relatively simple. Manufacturing yields were also quite low by today's standards. As metal oxide semiconductor, MOS, technology progressed, millions and then billions of MOS transistors could be placed on one chip, 80, and good designs required thorough planning, giving rise to the field of electronic design automation, or EDA. Some SSI and MSI chips, like discrete transistors, are still mass-produced, both to maintain old equipment and build new devices that require only a few gates. The 7400 series of TTL chips, for example, has become a de facto standard and remains in production. Acronym name: year, transistor count, 81, logic gates number, 82. SI small scale integration 19641 to 101 to 12 ms IMADI scale integration 196810 to 50,013 to 99 LSI large scale integration 19715000 to 2000100 to 9999 VLSI via large scale integration 19802000 to 10000001000 to 99999 ULSE ultra large scale integration 1984100000 and more 100,000 and more.